Hello and welcome to the lecture. This is where we stopped last time. We were looking at the uses of the break and the continue statements, where we use some of the either for loops or while loops or some of the conditional statements before. So in the next example, we'll see how those break statements and continue statements affect the flow of the program. So let's get started. So in this example, you see in the first one here, we have the use of a while loop. We start the variable n at 5, and we're testing for the case where n is greater than 0. So while n is greater than 0, then the statement is going to continue in printing the number associated with n. So, and in this case, as you see in the first line of the statement here, the value of n is reduced by 1, okay, through each iteration. So obviously, in the first case, we're going to start with n equals 4, and the question or the test is if n is equal to 2, then this program is going to break. In other words, it's going to leave the while loop. But since in this case, the first time is 4, it's just going to print 4, as you can see here. The second time around again is going to reduce n by 1, so n is still 3, not equal to 2, so it's not going to break, but it's going to print 3, as you can see here. And the next time around, obviously, then n is equal to 2 at that point, so at that point, it's going to break out of the while loop, but it's going to print, or it's going to go to this statement, it's going to say loop ended, okay? So when n becomes 2, the break statement is executed, and the loop is terminated completely, and so the program execution then jumps to this statement here. So that's the use of the break. You can break, or you can get out of a loop at any point by using the statement break. In the next example, which is the same program, but instead of using break, we use continue, so you see the difference between the two. And it's the same process, excuse me. It's the same process that we used before. We start n at 5, and in the same way, we're going to reduce n by 1 and test it against 2. In this case, however, when n is equal to 2, the continue statement causes termination of that iteration. And what that means is that 2 is not printed. So the execution is going to return to the top of the loop, and the condition is going to be reevaluated. And if it is still true, then the loop is going to resume, terminating when it becomes 0, as in the previous case. So you can see the difference here, right? It's just a way of breaking or pausing or changing the flow of the program by using the respective break or continue. Okay. All right, let's move on to the next case here. In this case, we have the else clause. Python allows an optional else clause at the end of a while loop, like you can see here. And this is sort of unique in Python. Most programming languages don't have this option, but you can see here that it could be useful. While this statement is true, this expression is true, then this statement will take place. If not, then this additional statements will take place. And of course, there's many ways of doing this same way in many other programs, and even in Python, but it's just another option. The other topic, or sort of, related topic that we can talk about, is the use of nested while loops. And in Python, in general, control structure can be nested within one another by using if, else, if, else statements that can be nested within one another. So we'll see some examples of this next. In this case, we try to find the average of numbers, and the Li is the ith number in a list which includes n numbers. So we can write a little algorithm to try to figure out how to find the average of the numbers included in a list that we call L. So as an input, we're going to have a list L that includes n numbers. And the output is going to be an average, which we're going to use the variable AVG that's going to give us the average of the numbers included in this list. So it's a simple example, but again, it's going to show us the use of the while loop in this case. So first, we're going to initialize a sum variable with the value 0, which is always a good programming technique. We're going to use the same thing with the variable I. We're going to initialize it as 0. And then we're going to say, well, what the variable I is less than n, we're going to do the next steps from 4 to 5, these 2 steps. So we're going to keep adding the individual numbers to a sum, and we're going to keep increasing the index. And when we reach that index or the end of the list in L, then we're going to add compute the sum or the average by computing the sum over the number of elements in the list. Okay, so it's a simple program, it's a simple piece of code, but it shows us again, for one thing, how you can implement algorithms, which is always a good idea to do first, right? To enumerate the steps you're going to do and then implement the actual program. It's going to help you in the long run, even though it takes time to do things like this, and we're not always doing them in this class because of the sake of time. But I always encourage you to do the algorithm first, to draw it, to enumerate the steps that you're going to do, and then write the program. Because if something goes wrong with the actual program, it's a lot easier to go back to the algorithm and change it. And even more than that, you can use this algorithm to create, other versions of the same algorithm, which is not as easy to do when you have an actual program. So get on the habit of writing an algorithm first and then the program. In any case, we then, for the algorithm, it's easier. Then we can then delineate the steps in the program. Again, we're going to find the average of numbers contained in the list L. Okay, and in this case, we have defined the list as including these 4 numbers. And the first thing we're going to do is find out the length of the list and put that in the variable n. We're going to initiate the sum and the index to 0. And so while this expression is true, while I is less than the length of the list, we're going to perform these 2 steps. We're going to add the numbers on the list to a variable sum, and we're going to keep doing that while we increment the index by 1 every time until the index reaches or goes above the length of L. And so when that happens, then we're gonna go out of the while loop and actually generate the average by performing the division and then printing the results. So, nothing really new as far as how we did it in MATLAB or you do it with any other program, but it's kind of give you the syntax that is used in Python. It's also important when you do this coding here that you be aware of the tabbing here. Okay, tab are very important in Python, and if we're using Spider, one of the things about Spider is that it actually tells you if the tabs are not aligned, and you'll see a red dot on the side if the tab is not correctly positioned. So, but it's also very useful to be aware that this statements make use of the tabs as part of the program. So in any event, once we run this program, that should be the result. Okay. So let's look at the next function here that we want to implement. And in this case, we're going to use more than one while statement. Okay. And in this example, we're going to compute the standard deviation of a list of numbers, just like before, right? Well, the general equation for standard deviation calls for the computation of the average of a group of numbers, which is this part here, right? And we've done this in the previous example just now. Now, we could have this average created as a function, which we'll later see how we can create functions. And we could have created this as a function and then call it within this new program. But instead, we're going to do it from scratch. In other words, we're going to first calculate the average, and then based on this equation, calculate the standard deviation. And you can see the result here. And in this case, we again created a list of initially 4 numbers, but we expanded that list 3 times by using the star3. So we have expanded that list to more than just 4 numbers. And then again, just like before, we computed the length of the list. We initiated the sum and the index to 0, and do the same thing we did before with the average. This is exactly the same thing we did in the previous example. And this will give us the average. And then to calculate the standard deviation, we'll start again with once that we have the average, we start fresh again with a sum and an index again. That's going to help us compute this part here, right? Because we're simply going to subtract every element in I from the average. And so that's what we do here, right? And of course, square that amount. So here, as long as I is less than n, or the number of elements on the list, we're going to compute this inside what's inside the square root, right? And compute the sum until this statement is no longer true. Then we're going to leave that while loop, and then compute the standard deviation by doing the sum over the number of elements and taking the square root, right? In other words, multiplying by or raising the result to the 1/2, which is the square root of the number. And in the end, we're just simply going to print the result. And you can see that here, right? We're printing average. And again, we're making use of some of the formatting we took a look at before. We printing the average and the standard deviation, and this is the output. So make sure you understand the flow here and how we got to the output. And you can do variations of this by, trying different lists of numbers and see, if you get similar results. Okay. All right. Now for the use of the for statement. Again, this is no different than many other programs and even MATLAB. So, but again, let's look at it in the context of Python. So again, the general syntax is that we have a for statement that includes a variable in, and then we have an iterator, which provides a countable number of values on demand, and then followed by a statement or a set of statements. They're going to be executed depending on, what this evaluates to. So in this next example, you see that we have a list of words, and it's called mixed. And so in this next example, splits the list of words into 2 lists. One list that includes the words that start with a vowel, and separated from the words that start with a consonant. So you can see here we have a list of elements here that are put in this variable mixed, okay, and that includes this set of words. Some of the words start with a letter, with a consonant, and some of the words start with a vowel. So again, the purpose of this little script here is to separate the two. So first thing we're going to do is, which is again, it's always a good programming advice, is that we start the vowels, which would include the list of words that have vowels. We're going to start that at 0. We're going to start empty in this case, rather. And the same thing for the consonants variable, which will include the words that have consonants in it. And we're going to start those with an empty list. So now you see here that if you look at the syntax, right, it says for word, which is the variable, right, in, which is the iterator, I'm sorry, which is the second part of the for statement, and the iterator here is mixed, right? So this is going to give us the actual, values that we're going to go one at a time. So if another, we're then using another command here, which is the if else, as you can see here, if word 0, right, so start at 0, is in or includes any of these vowels, then we're going to add the word, right, this word here, to the vowels case, whatever the word is. So it's going to seek for in mixed, right, which is the iterator in mixed, is going to look for any word that includes a vowel, right? And when it finds it, it's going to add that word to the vowels variable. If it doesn't include a vowel, then else is going to include that word to the consonant variable here, one at a time, right? And it's going to do that until it reaches the end of the mixed list. Okay, so it's going to start with a 0, right? With this element. It's going to place that into the words, or the word rather, the vowels variable, anytime it sees a vowel, a word that starts with a vowel. If not, else is going to put it in the consonant. So you can see that here, right? And the good thing is that we're showing the use of the for in statement and also the if else statement here. So it's a good little test for those type of statements. And then of course, when that is done, right, when the iterator is completed with the iterator, is then going to print the two statements, or the two statements with the vowels values and the consonant values. So you can see that here. So the result will be starting with consonants, the list of the words, starting with vowel, the list of the words that do that. Okay. So this is the key here. So you can see the use of the for in and the if in else. Okay. So make sure you understand that part of the little script here. Okay. Another example here. Let's look in some more details of this script. Look at the variation of the for statement. In this case, we're using range. Okay. So we start with a list of words that it saved on this variable word list, right? We have 1, 2, 3, 4, 5 words that are part of this list. And then we have another list called permutation, where we basically have numbers 4, 3, 2, 0, 1. We then go ahead and get the length of this permutation variable. And then we're going to create a new list. And in this case, we're going to create a new list with the non-keyword in it. Okay. And what we're doing is, I'll explain what none in just a minute. And so what we're doing is we're going to create a list called new list, a variable new list, that includes a set of elements in it of length, whatever the length of this permutation is, right? So if you see here quickly, if you see a new list variable, right, it's going to have 5 elements or 5 items because that's the length of permutation, right? Which is what determines the length here. Have 5 elements, and it's going to place none into each of those elements. The none keyword is used to define a null value or no value at all. It's not the same as 0 or false, and it's not the same as an empty string. It's simply a data type of its own. It's called a none type. And only none can be a none belonging to that data type. Okay, it's a specific data type, and it's used for many other applications, but it's important this point just to remember or to remind ourselves that is not a 0 value. It's not a false value, but it's used in many cases to define a data type. In fact, when we use later, when we get into functions, you'll see that some functions sometimes don't return a value, and when that value is not returned, is really creating a non-type. But in any case, for this particular example, it's not going to make a big difference other than to realize that it's creating a new list, and in the new list is originally created with non-type, almost like, there's nothing in it. There's nothing on the list when it's first created, right? Okay. So the other thing I want to mention again is the use of the range, as you see here. Okay, range is in its format. It includes a start index, a stop, and a step. The start is optional, and the step is optional. And it's sort of what you imagine what it would be, right? It gives you a start number, which is an integer. The 3 numbers are integers. And it says, basically to start this number and to take steps and to stop when it reaches this number in the middle. So you can start at any specific number, go in steps, and stop when you reach that number, okay? So in this example that we have here, if we look at range length, right? Like you see here, since the start is not specified, then by default, it's going to start at 0, okay? The step is not specified either, so it's going to go 1 at a time by default. But however, we have specified when it's going to stop. So when it reaches, if you see here, the length is 5, right? Because you have 5 elements. When it reaches 5, it's going to stop. So in this case, and that's important to notice here, because when it reaches 5, it's going to leave the for statement and it's going to do, whatever's next, which in this case is print a list. So let's look in this more detail in the next slide, okay? But just wanted to point out about the use of none to create this new list with 5 elements in it. And then the use of range within the for in statement. So let's look at this in detail in the next slide. So as you can see here, we have, just like before, the same script. We have a word list, right? And let's see, hold on, let's see. Yeah. Okay, we have a word list, okay? And we have a permutation variable. We computed the length of the permutation and we create the new list based on the length of this variable here. And so what it does is it's going to go from I in range, right? And it's going to compute the length. So it's going to start at 0, right? So the first time around, in this case, remember, range means that this computation or this part of the for in statement is going to start at 0, right? First time. And then it's going to stop when it sees 5 in this case, because that's the number of elements in here. So the first time around, it's going to do new list. This is going to be 0, the index, right? Because it's going to take on 0. Then it's going to take on word list, permutation. Permutation now is also 0, right? Like this one. So this is 0, this is 0. However, if you look at permutation, the permutation list, the 0 element here is 4, right? You can see here, right? So in other words, the when it looks at permutation 0, it's going to put 4 inside the outer brackets here. In other words, we put in word list 4, which in this case will be 0, 1, 2, 3, 4, right? From word list 4 into the new list 0. So at the end of the first statement here, new list 0 will have the word yesterday in it, okay? And it will continue to do the same thing again, right? Because the next time around, right, it's going to increment I to 1, okay? Started at 0. It's going to continue because it hasn't reached 5 yet. So the next time around, it's going to replace I by 1. And again, this is 1 and this is 1, right? But if we look at permutation 1 includes the number 3, right? So that means that word element 3, right, which is late, is going to be put on new list 1, right? As you can see, it's going to keep doing the same thing, right? It's going to do it for 2, right? So 2 is going to place home in the next one. And you can see, you can start seeing the output here, home, right? However, just because of the way that permutation is defined here, see what happens when it reaches 3, right? When I is 3, this is 3, and this is 3, right? So the word list index at this point inside the outer brackets is going to be 3, right? So as you can see here, 0, 1, 2, 0, 1, 2, 3 is late, right? So it's going to put late in that output, and it's going to continue doing that until it reaches 4. When it reaches 4, right here, it's going to put, this is going to be 4, this is going to be 4, and it's going to put the value that it sees here, which in this case is 0, right? And 0 here means that it's going to put he, right? Because it's the index now of word list. So it's going to put he here. And so the last one it's going to see is 1, right? If you follow the same logic, the last one it's going to see is 1. So word list 1, which is this one, is going to put into the new list as the last element. And when you see here is came, right? So you can see here now, once the important point I wanted to point out is that, look, it does that until it sees 4 as the length. But when I reaches 5, it's not going to do this. It's just going to leave the 4 statement and do the last thing or the next thing that it does outside the 4 statement. Okay? So length is the limit, but it doesn't do anything inside the statement. It just leaves when this becomes true. Okay? Another example here, in this case, at the bottom here, we use a matrix multiplication, and it's using the nested for-in statements, right? To follow this logic here, right? Where we multiply 2 matrices. And in this example, you can see that we use 3 for loops, actually 4 for loops, but 3 of them actually iterating the index length, which in this case, the index is 3, right? I'm sorry, the length of x will be 3, right? And so it's going to iterate that, this many times, computing the multiplication of the matrices. So the range goes, in this case, from 0 to 3, and we have used nested for loops to iterate through each of row and each column, and we accumulate the sum of products as the result. And the output, of course, is printed right here, right? So make sure you can follow that logic here. Again, the length is 3, so this outer statement is going to go from 0 until it is 3, and on this one is going to compute just the length of y0, right? For the second part, so we can multiply, every row with every column, every row of x with every column of y, like in the normal multiplication, as you can see here. And then finally, the result is going to be put in this result matrix, which has been defined here, initialized as 0. And by the way, this is not the only way we can initialize this with all zeros. There's many other ways we can do this. And so finally, the result is printed, as you can see here. Now, this is not a very efficient way of doing matrix operations. And later we'll see, and we mentioned this at the beginning, the use of NumPy or NumPy, some people call it, to do this kind of operations, which become more efficient when we use NumPy. So later we'll introduce NumPy and see how we can use this more efficiently. But this is just an example, just to show you how we can implement the use of for loops, nested for loops in the use of programming in Python. All right. So next thing I want to do is I want to move on to the use of functions. And in Python, again, it's not much different to many other programming languages, okay? But in this case, in Python, the function definition starts with a keyword DEF. Okay, DEF indicates that a function is being defined, and it's going to be followed by a function name, which again must follow the variable naming rules that we need to follow for Python. And it's going to follow by a list of parameters being passed in parentheses, and they're going to be separated by commas. Now, these parameters can be omitted, like we see in some examples, right? But if we include them, if we have one or more, but if they're more than one, then we separate them by commas. And then once we define the parameters inside the parentheses, we need to include a colon, okay? Because that indicates the end of that portion of the function definition, because what follows will be a statement or set of statements that will perform some related task that we need for that particular function. So, and sometimes this is what is called a function suite, which includes the code that the function will perform. And it's very important that we use indentation here, right? As you can see, and we'll show this in a more clear example in just a few minutes. But indentation is very important when you define the function, okay? And again, in Spider, we actually point it out for you when you're writing functions. And then at the end of whatever statements we have a return value. The return statement indicates the value returned when the function is finished. We'll also see later on learn that the return statement may not be always needed. If the function doesn't return anything, we don't actually need a return statement. Okay, but this is the general syntax of what a function would look like. And there's some things we need to understand. Like we said before, the return statement indicates a value that is returned as output from the function invocation. A function's operation ends after a return statement is executed. That's it. In other words, once this is seen in the function, the program is going to leave the function definition. And a function may have more than one return statement, but the first one that is executed is the one that's going to end the function. Okay, so we may have more than one return function, as you see in some examples here. Sometimes we write functions without a return statement, and in that case, functions that do not return a value are called procedures. Okay, procedures. This is a special kind of function that doesn't include a return value. Very important. Indentation is a part of the function definition. Okay, again, it's part of the function definition. A comment used after the header of function is called a docstring. We'll see examples of that in just a minute. And a docstring describes the function, the inputs and outputs, what it does, etc. It includes whatever information you want to know about the function. And it has some special properties. It's always recommended that we use docstring. We'll see examples of this, so you'll see what that means in just a minute. Python docstrings are strings used right after the definition of a function, method, class, or module. They are used to document the code. They should not be descriptive. Rather, they must follow do this, return that kind of structure, ending with a period. In other words, it's more for understanding clearly what a function will do. Okay, it's like when you write or when you type help for a specific function, it'll tell you what that function will do. The docstring for a function should summarize the behavior and document the arguments and return values. We can access the docstrings using the underscore doc underscore attribute. Now, this is important here, and we'll see how that works in a minute. It's not difficult. But what's important here is that in order to use or to access the docstrings using this attribute, we're going to have to use 2 underscores in front and 2 underscores at the end. It's not 1, okay? If we use only 1, it will create an error. So it uses 2 underscores. We'll see examples in a minute. You can see documentation for any function using this attribute. Not just the ones you created, but for any kind of function already in Python. Okay, so let's look at some examples, make some sense out of this, okay? All right. This is a function, okay? PES tells Python that you're going to define a function. Celsius underscore 2 underscore Fahrenheit is the name of the function. This function includes just 1 parameter, okay? So when you call the function, what is called invoking the function, or when you invoke the function, you're going to have to include something in parentheses, because the function, and that something is going to be a number, obviously, because the function is going to expect that you're going to provide something in order to do what a function is going to have to do. Now here, following the first the definition, EF, the first thing we have is what we call before the docstring, okay? And the docstring, as you can see here, is taken as a comment, but it's a special type of comment because that information is going to then be used to describe what the function does. And it uses triple quotes, okay? And so whenever we see triple quotes after the DEF statement, it's going to be interpreted as a docstring, okay? And it's going to be taken as a comment. It's going to ignore whatever is inside the triple quote. So in this case, and we'll see in a minute how that's useful. So in this special, in this case, in this really simple function, all it's going to do is it's going to return a value here, right? It's going to return the value that you provide with Celsius underscore float. It's going to multiply that value by 1.8. It's going to add 32, and it's going to return the result. Now we could have saved this this result in a variable and actually return the variable, which is fine. But this is just a shortcut for doing that because this is just a simple function. But notice the use of indentation here, right? Indentation, again, is part of the definition of the function. If we don't have the correct indentation here, you're either going to get an error or it's not going to run correctly. So be aware of, using indentation in your functions. So in this case, the function is invoked or called when a name is followed by parentheses. The parentheses may or may not contain a list of arguments. In this case, it does. It is the parentheses that mark the invocation, or in other words, the parentheses is what tells the Python interpreter to call the function. And the name adjacent to the parentheses is the function that is being invoked. In this case, Celsius underscore 2 underscore Fahrenheit. So if we follow that logic using this information, you can see here that, okay, we have defined the function, right? We run it and it's in memory. So if I want to use it, then I'm simply going to call it. I'm going to call the name of the function. And this particular function, again, expects a number in parentheses. So I put that number in parentheses, and when I hit return, it's going to return the value computed by passing the number 100, which in this case will give me 212.0. Same thing here. If I pass 0, if I call the function and pass 0, it's going to return 32. Notice, however, that if I call the function and I put parentheses in it, but I don't put anything in it, it's going to return an error. Okay, simply because the function is expecting something inside parentheses, because the definition of the function is telling the interpreter that it's going to expect something inside parentheses. So if you just call the function without anything in parentheses, it's going to return an error. The same way will happen if you pass more than, in this case, if I pass more than one parameter, it's also going to give me an error because it's only expecting one. Okay, so just be aware of that. All right. Now, to make the definition like you saw here, right, we saw this name of the parameter, which is called Celsius underscore float. And then when you call it, you're actually using a number, right, associated with that parameter. And we're gonna we want to make that distinction. And the distinction is that one is called an argument and one is called a parameter. So, for example, this little example here, we have a function called greet underscore user, and it's going to expect a username associated with the function. Again, we have the docstring that tells us what the function will do. And the function is going to print, with this formatting, hello, the username. And then and that's what the function will do when we call it. This is the calling of the function, okay? The first 3 lines is defining the function. This one here actually is calling the function from outside the definition, okay? If it's not clear. So in this function, the greet user function, we define greet user to require value for the variable username. Once we call the function and gave it the information, which in this case will be a person's name, it's going to print the greeting here. Okay, excuse me. It's going to print the username. The variable username in the definition of the function is an example of a parameter. A piece of information the function needs to do whatever it needs to do to perform the statements we need to perform. The value in this case, Jesse, in greet user, right, which what we call it, we passing this Jesse value is an example of an argument. So the parameter in this case is username. The parameter is username, and the argument in this case is Jesse. So the parameter username doesn't change. It stays the same, but the argument changes. It's like in the previous example, the parameter name doesn't change. It's Celsius float. But what's inside, when we call it, the argument changes every time. So an argument is a piece of information that's passed from a function call to a function. When we call the function, we place the value we want the function to work with in parentheses. In this case, the argument Jesse is passed to the function, and the value was assigned to the parameter username. So the argument is assigned to the parameter. Okay, so it's just a separation definition between these two values here, parameter and the argument. Okay. Okay. Now let's look at passing more than one number of arguments, in this case, an arbitrary number of arguments to a function. How do we do that? Sometimes you don't know ahead of time how many arguments a function is going to need to do what it needs to do. But in Python, it will allow you a function to collect an arbitrary number of arguments from the calling statement. And for example, let's say we use we want a function to build a pizza, the components in the pizza. Okay, it needs to accept a number of toppings, but you can't know ahead of time how many toppings a person will order or will want in a pizza, right? So in this example, the function has one parameter, and we call that start toppings. Okay, but this parameter collects as many arguments as the calling line provides. The special case is here that we use in the parameter with the asterisk followed by the parameter, and it tells Python that to make an empty tuple that is called toppings, right? So once we define the function, right, with the argument start toppings, is going to take however many arguments you're going to pass it. So when we call the function here, for example, if we call it the first time, the name of the function is make underscore pizza. And in this case, we're only passing one argument to the parameter, right? And because of the star toppings, right, it's gonna put the information in this toppings parameter, and it understands that it can take more than one. So the first time we call it, we just pass one, and the second time we call it, we pass in 3 arguments to the parameter. But the special case here is that when we define the function, if we have a star or asterisk followed by the name of the parameter, the function understands that it could expect one or more. Okay, so it's just a special case. Also, another example of using multiple returns. In this case, we have a function called positive underscore negative underscore 0. Okay, there's a definition, and it expects a parameter, a single parameter called number. Okay, and it's followed by the following statements. Of course, we're making use of if, else, and so forth. And again, notice the use of the annotation here, right? Very, very important. So in this case, it's simple. It's a simple function, and it's simply saying, well, if the number is greater than 0, return positive. If the number is less than 0, return negative. Else, return 0. Okay, very simple. So the function works correctly whether the argument pass is an integer or a float. But in this case, it will end depending on what number we are sending to the function, right? So at any point, depending on what that number is, the function will return the result and then end, right? So you can see here, if we send a negative number, it says if number is greater than 0, no. So it's just going to follow with the next if. If the number is less than 0, yes, it's going to return the result as negative, and it's going to leave the function. So as you can see here, this function includes several return statements, which will force the function to end at any point along these sentences here, these statements. But it's not always a good idea to use many return statements because it can make things confusing. Someone looking at your function. So you can use many return or several return statements, but always try to use as little as possible. Okay. All right. Now let's look at how we can use or access files in Python. You know, how we can read files, how we can write to files, and so forth. In Python, the open command sets up connection and returns the file object that represents the connection. So that's how we open a file with the open command or the open module. All subsequent actions we perform on a file are done through this file object, also sometimes called a file descriptor or stream. A file can be opened for reading by using R, lowercase r, or writing by using lowercase w. If we put them both together, WR, we can open it for reading and writing at the same time. Once a file is open, you can print to the file by adding the file equal argument to the print command, and we'll see examples of this in just a minute. And it's always recommended to close files, because when you open a file, you're using resources in your system, and you just want to release those resources at the end and make sure that you're not wasting resources in your computer. When we want to read from or write to a file, we need to open it first. When we are done, it needs to be closed again, so the resources that are tied with the file are freed. So in Python, a file operation takes place in 3 steps. We open a file, we read or write, and then do whatever we want to do with it, right? If we read it to do something. If we write to it, we write something to it. And then we close the file. It's as simple as that. So to open files, Python has a built-in open function to open a file. This function returns a file object that is also called a handle and is used to read or modify the file accordingly. In this example here, the handle that is returned is placed in this variable f. Okay, and we'll see how we can then use this handle f to access the file and do things to the file. So to open a file is as simple as that. You use the command open in parentheses. In this case, it's going to try to open a file called test.txt, which is always going to look for the file with in the current directory. If it doesn't find it in the current directory, it's just gonna give you an error. But you can also specify where the file is located. If the file is not located in the current directory, you can give it a path, right? So in this case, if you specify the path, it's going to go to that location and open the file and create a handle that is then placed, in this case, in this variable f. Again, this is a variable. It could be any name here. Okay? It doesn't have to be f. We use an f in a lot of the following examples, just to keep it short. But the name of the handle could be any allowable variable name. And we can specify the mode while opening a file. The mode, we specify whether you want to read it. We use R, write, W, or append using the letter A to the file. We can also specify if you want to open the file in text mode or binary mode. The default is reading in text mode. In this mode, we can, we get strings for reading from the file. On the other hand, if we use binary mode, it returns bytes. And this is the mode we can use to read images or executable files. And this is a summary of the description associated with each of the modes. R is for read, W for write, A is for append, and those are the main ones we're going to be using in the next example. So like we said before, it's important that we close the file. When we're done, we need to properly close the file. Closing the file will, again, free up the resources that we were using associated with that file. And it is done using the close method, okay? So we can simply say, open file, and then when we're done with it, we can use close and close that file. Python also has another way of closing files, which they consider it to be safer, okay? And so what they use is what's called the try, and then something in between finally set of statements here. Now, this again will accomplish the same thing you accomplish with just saying if close. It's going to be the same thing. But this way, Python guarantees that the file is properly closed, even if an exception is ready that causes the program flow to stop. In other words, let's say, for example, you're reading a file and something happens, the reading crashes or something, then or you did something to the file, like writing information to it, and the program crashes, that information will be lost, even if you have closing here. Okay. With this method here of try finally, there's the chance of losing the information are less. Because this performs other operations in the file, is keeping track of other operations in the file that makes it safer to close the files. So, the end result will be the same, but just keep that in mind, okay? And we'll see examples of this in just a minute. So, we saw how we read files, how to open files, how to close files. Now, for writing files, in order to write files in Python, we need to open it in write with the lowercase w. We can also use append with the lowercase a, or exclusive creation x mode, in which is with the lowercase x. I'm sorry. And if you use this this mode, it opens a file for exclusion creation. And if the file already exists, it's gonna give you an error, because it's gonna tell you the file already exists, so you don't overwrite it or do something to it that you don't want to change. So it's more of a protection when you're writing. So it's the same as write, but it's gonna avoid it if the file already exists, just to protect it. So we need to be careful with the W mode, as it'll overwrite into the file if it already exists. So if you write something to a file, it's going to overwrite it. And all the previous data is going to be erased. Writing a string or sequence of bytes from binary file is also done using the write method. This method returns the number of characters written to the file. So this is an example of writing a file, when we're basically doing is we're creating a file. So as you can see here, we're using the try finally set of statements to open and close the file. So the first statement here is to open the file. And what it does is, since it's using the mode write, it's going to write the next information that I have on this script to this file that I'm creating, right? So this is the name of the file I'm creating with the extension txt, okay? And so it's going to write the next set of statements. And so in this case, it's just 3 little statements, right? And using, regular formatting. So it's /n creates a new line. So it's going to create 3 lines. So it's writing every time I said F. F again is the name of the handle of the name associated with the file that I'm using, which again could be any name here, but I'm using F just to keep it short. So f.write writes this first line to the file I just created. Okay. Again, if the file already exists, it's going to overwrite it. If it doesn't exist, it's going to create this file under the name you give it. So it's just a simple file that I'm creating with 3 lines, the first line, second line, and the third line. And then once I'm done, I'm going to again use the finally followed by F close. And as you can see here, he created this file with the extension txt. And inside that file, if you look at that file, it includes the 3 lines I included in here, right? So simple. I open a file to write to it. I give it a name that I wanted to have. I put the information I want inside the file. I close it, and then the file was created with the information I have. Okay. Now to reading files in Python, we use the file in reading mode with the lowercase r. There are various methods available for that purpose. You can use to read the file. We can use the read parenthesis size method to read in the size number of data. If we don't specify the size parameter, it reads and returns up to the end of the file. And so let's look at examples of that using the file I created previously, right? I created a file with the extension txt. I wrote 3 lines to it. Now I'm going to read some of that information. So to read it, again, I'm going to, because remember at the end of the creation, when I created the file, I close it, right? So if I want to do something to it now, I got to open it again. So I open the file, and I'm going to open it in the reading mode, right? So I'm telling it, I'm going to open the file. I want to read it, and the file I want to read is this. I give it the name of the file, and again, I'm going to put a handle in the variable f. So if I want to read something out of the file, I can use this method called read parenthesis size. If I don't put anything, any number, size is an integer. If I don't put anything inside parentheses, and if I do f dot read parentheses, it's just going to read a line at a time. Okay, so in this case, it's going to read the first line that it sees in the file that I created. Okay, so let's see now other examples. We can see that the read method returns a new line as /n. Once the end of the file is reached, we get an empty string when we try to read it even more than that. And we'll see examples of that in just a minute. We can change the current file location or the position if we use the seek method. And or if you want to know the current position of what we read in the file, we can use the tell method. In other words, it's like reading a book, right? If you want to, like if you read line by line or word by word, you can use these 2 commands, these 2 methods to read specific portions of the text you created. For example, here, if we use, again, we're going to open the file, right? For the very first time here, fresh, right? And we're going to read that file that we created. And if we use the method ftell parentheses, it's just telling me that when I first read the file, the current position of the file is 0 at the very beginning of the file. Now, if I tell it to read the file, but I give it a number 4, it's going to read the first 4 characters that I have in that file, in the text file, as you can see here. But it's going to read up to the 4th character, right? Again, if I ask in what position is the file at the moment, again, I can use ftell, and now it's in the 4th position. So it's like moving the cursor, right? I'm moving the cursor. When I first read the file, the cursor is at position 0. I then say read up to 4, so the cursor is moved up to the 4th character. So if I ask the program or the Python, where's the current position of that file, it's going to tell me it's at position 4. Okay, so that's how you can tell where you are. If I then go back and read this, if I use this read, it's going to read the file, but I already put the file cursor, if you will, in position 4. So it's going to read the rest of what's in that file after position 4. Okay, so think of this as moving a cursor, right? Each time I read a file is moving the cursor position if I use this tell or read commands. So now that I read everything here, if I do another read, since I already reached the end of the file, we get this empty string, right? Because I reached the end of the file. If I want to go back to the beginning, right? If I want to read the file again, going back to the beginning, I'm going to use the seek method, and the seek method is going to put the cursor, if you will, back to position 0 in this case. I can put it anywhere, right? But in this case, if I want to go back to the initial position of the file, I'm going to use seek with the number 0, and it puts it back to the initial position. So if I do another read again at that point, now it's going to read what's inside the file. Okay, so that's how you can manipulate reading elements or sections of a file. We can also use the read line method to read individual lines of a file. And this method reads a file until the new line is found, including the new line character is found. So I created a very similar file again, but this time I added more lines to it. So you can see here. So I have, again, I'm writing a new file. What this will do actually is going to overwrite the previous file I created, unless I give it a different name, of course. Let's see, if I keep in the same name, it's going to overwrite what I had before, but this time I'm adding these lines here. One thing to notice here is that, remember that when you writing a script, if you want the line to continue, just use a backslash like I'm doing here. So in this case, this line here, right, for continuation, I indicated with a backslash that continues on the next line. So this is, taken as one continuous statement. So that's all I'm doing here, creating a new text file with this information in it, and I'm using the try finally to close it. So that creates it and close it. Now I'm going to read it, but I'm going to use this method read line to read one line at a time. So again, I'm going to open the file, right, with the R mode, because I want to read it. And if I do f.read read line, it's going to first read the first line by default. Okay. So as you can see, it's going to read the first line and show it to me. And if I do it again, it's going to read the next line. Again, it's like moving from line to line. And it's just going to read the next line that you can see here, right? And if I said read line 4, well, it's just going to try to move to the position where it finds the next line, because this reads the first line, right, which is this one here. This one reads the next line, which is this here, until it sees the end, right? And then at that point, the cursor is here, right? So if I said read line with a number, it's going to read the next line, which is this one, which includes the first 4 characters. And as you can see here, there's a space here that is taken as a character. So what it's going to give me back is just PYT. Okay. Now again, if I continue, right, if I haven't done anything, if I keep that sequence, at this point I'm here, PYT. So if I do F read line again with just empty parentheses, is going to continue where it left off, which starts at HON until it sees the end of the line. Okay. And if I continue that way, you see that the next line is an empty line, right? You can see here because I have two next line commands. So if I continue in that sequence, this command will simply print /n, which is the command for the next line. So after this statement, I'm right here. So if I do another read line, it's just going to read the last line in the text file. Okay. One more thing, if I use the read lines method, this one returns a list of the remaining lines of the entire file. And as you can see here, again, I'm opening this file for reading, right? And then the file that I just created. And if I do, like before, if I do read line, it's just going to read one line at a time, right? Like I did previously. So read line is just one line at a time in sequence, if I keep that sequence. But if I do read lines, it's going to read the entire document, okay? So again, if I do read lines, it reads the entire document, right? It reaches the end. If I try to reach the next line doing read line, it's just giving me an empty string here because there's nothing more to read. And that's how that's one way of knowing when you reach the end of a file, for example. All right, a couple more things that are important. Sometimes we want to get current directory information, or we want to do things to a directory. So if you want to get the current directory, we can get the present working directory using the method get cwd. But we first gotta specify the operating system. Of course, this applies to not just Windows, but any Linux or Mac or any operating system. So Python needs to understand first what operating system we're using so you can know how to access the directory information. So in this case, to get directory information, we first need to use this import OS statement. That import OS statement will make it clear to Python that we're using, whatever operating system we use in our computer. And then we're going to use the get cwd method to get the directory information. So we're going to follow that by os.getCW parentheses, and that will tell us the current directory we're in. See? That's very important, right? If we need to know what directory we're working on at the moment. If we want to change the directory, though, we can do that by using the chdir method, okay? And if you want to change it to a new path, the new path that we want to change must be supplied as a string. And we can use both the forward slash or the backward slash to separate the path elements. They both work. So in this case, again, I've used this import OS, and I can then tell the system to change the directory. So I use os.chdr, and in parentheses, I place the information of the path where I want to change, right? So in this statement here, we'll change the directory to this location. So to check, I do another print of os.getCwd like I did before, which gives me the current directory information. So as you can see here, the current directory information has been changed to this location. If I want to have a list of directories and files inside a directory, I can use the list dir method. Again, as before, remember, if I print the current directory information, this is where I am. If I use the os.listdir parentheses, it gives me a list of the files and subdirectories under this location. And this is just a partial list. I didn't print the whole thing, but because at the end, you'll see the close bracket tells you that you reached the end of the information of all the files or directories included in here. So that's how you can tell what directories or files are located, in this particular path. If I want to make a new directory, I can use the mkdir method. The method takes the path of the new directory. If the full path is not specified, then the new directory is going to be creating in the current working directory. Okay. So in this case, I want to create a new directory called test. So I simply make use of os .mkdir in parentheses the name of the directory I want to create. And as you can see here, if I do os list directory here, it'll tell me that I created that directory in here. Okay. The last thing I want to talk about is removing a directory or file. And for that, we can remove or delete a file or directory. If you want to remove a file, we use the remove method. And if you want to remove an empty directory, we use the rmdir method. Okay. The rmdir method can only be used to remove empty directories. Okay? If it's not empty, I cannot use this method. I'll show you the next example how to do that for not empty directories. But in any case, in this example now, just to see what directories I have two directories. I know that because I'm using listdir to see what directories I have under this path. And I have two, one called new, one called old.txt. One is a file, one is a directory. So I want to remove the file. So to remove the file, I'm going to use the remove method. I use os.remove, the name of the file, and that will delete the file. If I want to remove the directory, this one, I'm going to use os.listdir parentheses, and that will remove with the name of the directory I want to remove, and this will remove the directory. So if I go back and by the way, if this directory is empty, I can use rmdir to remove that directory. Okay. Oh, and I'm sorry. This here is just listing the directories I have, right? Okay. It's just listing. If you follow the sequence, right? Originally, we listed what I have in this directory, list dir, and I have one directory and one file. I then went ahead and removed that file, right, using .remove. So this statement here removed that file. So if I go back and use listdir again, now I remove the file. So all I have is this directory, right? Because I remove it by this statement. So if I go back, now I want to remove the directory, I have to use rmdir. So I use os.rmdir in parentheses, the name of the directory I want to remove. This will remove the directory. So if I go back to the first statement that I have, after this statements, and I do list directory, I have nothing, because the first statement removed this file, and the second statement removed the directory. And so when I look back at what I have inside that directory, I have nothing, right? It's an empty string. Okay, so but this again, this is used to remove directories that are empty. If I have a directory that is not empty, I use the rm_tree method. And this is used inside this SHUTIL module. The SHUTIL module stands for a shell utility. It's got a lot of uses, which we're not going to go into in this class, to manipulate files and do all kinds of things with files. But in this case, just to show you how you will remove a file that is not empty, you will first have to import this utility, import SHUTIL utility. Because if I try it again, let's say, for example, I have a directory here, right? I'm going to list it. This test directory is not empty. It has something in it, assuming that it has something in it. If I try to, if I'm going to list what I have, and I have this directory called test, right? Is not empty. So if I try to remove it with the rmdir method, it's going to give me an error, and it's going to tell me the directory is not empty. Right. So if I want to remove it, then I have to use this rm3 command. But before I can use the rm3 command, I have to import this utility here. So I import that utility, and then I can use it as a method, as an object. So I use SHUTIL dot rm3, the name of the directory I want to remove. And this statement here, this single statement, removes the directory, even if you have information in it. There's no warnings, by the way. So if I do another list directory, it's going to be empty after this statement. Okay. All right. So that's all for today, and we'll see you next time.